We're studying IGCSE physics, and we're starting the Earth in space. Now, in your syllabus, it's called space physics. Our job here is to realize how does the sun and Earth and all the orbits work, about the axes, about the seasons. We look at orbital velocity, we look at redshift, and all of that. We look at bodies in space, and we'll also look at the age of the universe. Yep, right here, age of the universe. So we'll do that in a second. Let's start from here.
By bodies, do you mean like the people that have died in the space?
Oh, that took a dark turn. Well, by bodies, I mean objects in space, like asteroids, comets, all of that. Now start from here, quick. Amina, start reading, quick, hurry up.
The sun. The sun is a huge glowing ball of gas called a star. It is extremely hot with a temperature of 6,000 degrees Celsius on the surface, rising to 15 billion degrees Celsius in its center. Its energy is released by nuclear reaction in its core and it radiates mostly in the infrared, visible, and ultraviolet regions of the electromagnetic spectrum.
All right, stop. Now, what we realize here is the sun is hot. All right, we know that. But what kind of waves is it emitting? It's emitting three kinds of waves: infrared, visible, and ultraviolet. Now, infrared is what you feel as heat, visible is what you see, and ultraviolet is basically has a higher frequency. It penetrates your body. We look at all of these in detail later. Now continue. Try read.
The Earth, day, night, and seasons. The Earth turns slowly on its axis once a day. Half of the Earth is in sunlight, and half of it, and half in shadow, in darkness. As each place moves from sunlight into shadow, it passes from daytime to night. Should I read the diagram out?
Not the diagram, not reading the diagram.
Okay.
I just want you to read from here. Ayan, read from here, quick. Till here.
The Earth moves around the sun in a near circular path. The path is called an orbit, and the Earth's orbit is just over 365 days, or 1 year. The Earth's axis is tilted by 23.5 degrees Celsius, as shown in the diagrams.
All right. Now let's go back to the whiteboard. Can you see the whiteboard? Space physics 1.
Yes, sir.
Space physics. First thing first, we're looking at the Earth, and we'll start with a few things. We look at what is Earth, right? What is Earth? Well, Earth is basically rocky planet in orbit around the sun. All right, it's in orbit. It's like, let's say, in a circular orbit. It's not perfectly circular, obviously, but it is kind of circular. Next thing we realize is, well, it's orbiting around the sun. All right. How does it orbit? It has two things. It rotates and revolves. Let's look at rotation first. So what does the orbit mean? Orbit includes two things: rotation and revolution. Rotation causes day and night. Let's just say rotation, and revolution. What does this mean? Well, if you have the sun in the middle, right here, that's your sun. Just a second, right here, this one, that's your sun. And we have a planets around it, and this is our Earth. Fine. The Earth is this whole thing is called revolving around the sun. All right. That causes days and years. All right. This causes, let's just call it year, and this causes night and day. Now, what is the meaning of rotation? This is what it means. Can you see that? That
Yes, sir.
rotation in its axis. So while it's revolving around the sun, it's also rotating like this from at an axis. So if I make a spherical Earth, let's look at the diagram again. Right here, it is revolving around this axis like a top. Right? If you spin something, it rotates. But the angle, which is important, is 23.5. Write this in your notebook. Start. Write all of this and start with rotation. We mainly focus on rotation first. First thing first is axis of rotation. Axis rotation is equal to 23.5 from vertical. So if you have the Earth like this, like here, this, your axis of rotation is actually this from the center, and this angle is going to be 23.5 from the vertical. If I remove this, this is what your Earth looks like. Now,
Do we draw the Earth as well?
no, not at all.
Okay.
Now, next thing is actually you should just draw the circle and a line like this, make a normal or make a vertical like this. In the exam, you need to be able to label it. Well, not really label, but they'll ask you. They'll ask you what is the axis. Next thing is time for one full rotation is equal to 24 hours. Duh. Neha, any questions? Now, Neha, I want you to read from here then. Quick.
Okay. Rotation, axis of rotation is equal to 23.5 from vertically. Time for one full rotation is 24 hours.
24 hours. Now, what causes day and night, right? The reasons are, first thing, rotation of Earth. Earth, let's say makes or allows or makes one side of Earth face the sun and the other face away. Now what this means is, or that's what happens. If you rotate it, one side will face the sun, the other will face away from the sun in a periodic cycle. Face away from the sun, causing day, and the other face away, causing night.
Okay. Can you scroll up so I can see like the content and just write it down quickly?
Yep.
And
Amina, read
remove
from here.
Can you remove the? Yeah, thank you.
Cause of day and night. Rotation of Earth makes one side of Earth face the sun, causing day, and the other face away, causing night in periodic cycle.
That's it. So basically in a periodic cycle of how much? 24 hours. Now rotation, write one more thing here, rotation around its axis. Right, the axis is 23.5 degrees or 24 degrees from the vertical. Periodic cycle of 24 hours. Just need to type it as 24 hours.
What is 23.5?
Yeah, that is the angle
Angle of
the axis. Look, if I have a vertical like this, okay, but I rotate it, let's say to some degree. If let's say I had Earth and I rotate the Earth like this, okay, Earth was actually like this, but in reality it rotates like this, and that is how it's rotating around, revolving. Now, if I have the sun, I have the Earth like this, okay, and if I create one axis, imagine the Earth like a top, right? Like something that rotates, like a top, okay. And if I rotate it, Earth will rotate in this motion like this. That is how top rotates.
Yeah.
But in reality, it doesn't rotate. This is not what's happening. What's happening is the Earth is actually like this, and the rotation is actually like this. Is that clear?
Yeah, got it.
And this angle, which the deviation is called is 23.5 right here. Just make this thing
Okay.
right here. Like, Ayan, any questions? Anas?
No, sir.
No, fine. Let's continue with something. Now we know what day and night are. Well, we need to know what an equinox is as well. Let's see. Or let's start with rising and setting of sun. Now the equinox is basically area where sun rises exactly in the east and sets exactly in the west.
Someone's mic is on.
No worries, no worries. I want everyone's mic to be on actually. Well, if you were studying in a classroom, you'll have much more noise, right? Unless it's disturbing, I would prefer if you keep your mics on. Now, any questions, anyone?
No, sir.
Now, what does this equinox mean? Well, let's look at Earth like this. Let's say this is a land, and I have some houses here. Okay, beautiful houses, and it's floating in air. Fine, magical house. What's happening is there's one more thing happening, which there is a sun, and the sun is actually setting and rising. But in some places, it's not really exact, right? Now, this area, if this was an equinox, the sun would rise exactly in the east from here and set exactly in the west, right? This is north, north, south, east, west. Rises from here, sets over here. Now, this area is called an equinox where this happens. But the problem is, in reality, the angle the direction doesn't change, but the angle changes, okay? Or the exact location changes for the rising and setting. So we'll see that. So let's say position or setting of sun or sun's position in northern hemisphere. Or let's just say seasons in the northern hemisphere. Now, first one is in sun rises north of east and sets north of west. This is summer. But the opposite happens in winter. Sun rises south of east and sets south of west. And I start writing quickly. Now, what does this mean? What is the meaning of north of east? Well, north of east is like right here, that. The sun actually doesn't rise from the east, but it rises from here. And it doesn't set there, it sets over here. Look, that is how it changes. It actually looks like this now. The bending is different. That is in summer. The sun is actually much higher in summer. Then east, it's even more north. But in winter, the opposite happens. In winter, it comes from here. Let's say from here, and rises even lower.
How does the season affect this?
Because look, when the Earth is revolving, okay, at certain times, some areas of the sun are facing different areas of the Earth. What this really means is, look, in summer you have a lot more sunlight. Okay, why is that? Because the Earth, the revolution is directly facing towards the sun for long periods of time. But when it's winter, your side of the Earth is actually facing away from the Earth for longer amounts of time. Now, what that causes is it causes the axis of the rotation to change slightly. Now, this rotation doesn't change, but respective to sun over here, let's say sun right here. Okay, this area is is always usually more away from the sun. Or let's say the area below. This one is directly towards the sun, area top. But after some time, what will happen is this area will be towards it. Right, the bottom is now towards the sun, and the top one is away from the sun. So the big thing is, all you need to do is remember what happens to the directions when the seasons change. Is that clear?
Yeah.
Now look, so top is north, and bottom is south. We're looking at northern hemisphere. Now, when the north is facing the sun, okay, that will be summer. But in this area, in the second position, north is facing away from the sun, isn't it? Neha, in the second position, compared to the first one, where is the north facing? Neha, can you hear me?
Yeah.
Now look, north is the top of the Earth. When the Earth is here, respective to the sun, is the north pointing towards the Earth or away from the Earth?
Towards.
Towards. So that means it's going to be summer in the northern hemisphere.
Yeah.
Now look, in this position, in the second position, is the north pointing towards or away from the sun?
Towards.
No, north.
Oh,
North is top.
north. Okay, sorry. I couldn't see because of that text. Yeah, away from it.
Away. Therefore, this will cause winter. This north. Over
Yeah.
here and summer over here. So the yellow parts are the summer, and the rest are winter, basically, right? I hope that makes sense. Now, all you need to focus on this, memorize it, and we'll be doing some questions on it from the
Wait,
workbook.
can you go to the part where the equinox part?
Right. The next thing we have to look at is, let's see from the book. Has everyone finished writing?
I'm just writing the last part, the seasons
Almost, sir.
in the northern hemisphere.
The equinox part.
I'll give you a few more things, a few more information. All right, just do one thing, write one more point here. Seasons cause change in, let's say, change in positions of rising and setting of sun. That's what you need to write as well. Now we look at questions that will make things easy. Let's look at a few more things, such as we look at one more basic information, that sun is highest at noon and directly above, basically above horizon.
Sir, can you show the diagram, the one with the house and everything? Yeah.
Now, yeah, you should make this diagram, by the way. It will help.
Mhm.
All you have to show is winter is below, summer is higher. That's it. Now, okay, just a few more things. All of you, please tell me when you finish writing.
Wait, I have a question. So for rotation, like the first thing we wrote, axis of rotation and time for one full rotation are points of rotation, right?
Yes, yes,
Okay.
those are points for rotation. Yes, like these are points for seasons, right? These are points for seasons. Just add one title here if you want to. Or these are points of rising and setting, basically. And these are points for rotation. Now, all of this part is inside the rising and setting of sun part. Equinox is basically where it sets exactly in east, and where it rises in east and sets exactly in west. What is the winter solstice? That's when the sun is highest point in the air. That means is the sun is most away from you. What that means is, again, since it's most away, it's going to be colder than the other days, right? And in summer, what happens is it's at the lowest point, it's closest to the earth, so therefore it's the highest temperature on that day.
But that will be only for one part of the earth, right?
Yes, right. So different areas have different days, right? So you'll have to check the day for your area. Now, it's not that different. It's not going to be dramatically different, but yeah, the timing may vary a bit. Because we need to realize that the orbit is not really the perfect circle. It is a bit like this, right? If the sun is right here, this area is slightly bigger than this area, and the earth rotates like it's an ellipsis. It's not a perfect circle.
I'm done writing.
Ayan, tell me.
I just have winter solstice and summer solstice left. Give me a second.
Almost, sir.
All right, the next thing we have to look at is okay,
I'm done.
finished. Good job. All right.
Yeah,
Now I
once
will
again,
read the book.
winter solstice.
All right, take your time. Now, one thing we need to talk about is the next thing we have after this is the phases of the moon. We have the orbit velocity, the equation for that. And after that, we'll be looking at key things such as the solar system. Just a second. All right, what I want you to do here is I want you to write a few more things. The next thing is what causes seasons.
All right, done writing.
May I read from the beginning?
Okay. What causes seasons? Because of the tilt in 365 days, some areas are more head onto sun and receive more hours of sunlight than others, causing summer. Other areas receive fewer hours of sunlight, causing winter.
All right. Just add one more line. Let's say surface areas. Right. Let's just put that word in there. Surface. Now what that basically means is, look, this is the Earth, okay, and you're receiving sunlight. Now because of the tilt, what's happening is this side. Let's compare these different sides here. We have this side. We have this side. This side. This side. This side. This side. And this side. Now, can you tell me which side is getting more sunlight? This point or this point? Point A or B?
In chat.
Say that one more time. Which side is getting more sunlight?
In the
This is Earth,
chat.
yeah,
Or
no, out loud, not in the chat, out loud. So the person who answers first gets 2 points.
A.
Right,
Let's
we
say
have A. So Anas won by a few seconds. 2. Ayan got 1 point. The rest are 0. And Neha is also 0. Right. Now, A is getting more, so north is facing having sunlight. Fine. But if I rotate it a bit different, now which side is getting more sunlight? Quick, first one to get answer.
There's B.
B. So I think Shreya was first. Ayan,
I was
Amina, and Neha.
Yes, sir.
So 3, 2, 0, 0. Amina, Neha, where are you?
Sir, here only. Yes.
I was gone for
Here
a
only,
bit. I
right?
just
But you have to tell me before you leave. Now what's happening is you're getting more sunlight, more heating because of these areas. You can make this diagram in your notebook. Actually, don't do it. Waste of time. You can read this from your book as well, and you can check your notes later. That's it. That's why you have seasons. Well, next part, the moon. Let's to start this part of the chapter. Let's first look at the moon, if you haven't already. This right here is the moon. Okay, and that is it. It's in the sky. If you look at night, you'll find it.
that's
Now,
a moon.
yeah, that's a moon. Yeah, it looks white in color. Now, one thing is, what do we need to know about moon, right? Well, what is a moon? Moon is a natural satellite of Earth.
Satellite, yes.
It's white in
It's not
color.
artificial. It's natural. It's white in color. Yeah. Now, Anas, more focus on the definition and in your notebook.
It emits light.
It reflects light.
It reflects the light received from the sun.
Yes. I think I'm right. Right? So you're on mute if you're speaking.
Guys, can you hear me? Hello.
Yes, yes.
All right. My internet is lagging a bit. Now, this is the moon. What you have to know about this is the orbit of the moon. It does reflect light. Yes, it does. But that's not the main thing here. We need to realize is, let's read from here. Quick, Neha, start reading. Start. Neha,
Yeah. Sorry. Yeah. I'm supposed to read that part.
yes.
Okay. The moon moves around the Earth in a near circular orbit. Each orbit takes about a month, or more accurately, 27.3 days. The moon also takes 27.3 days to turn once on its axis, which is why it always keeps the same face towards us.
All right. Now, what we realize is the moon is not rotating, it's only revolving. What that means is we can only see one side of it, the rest is never seen. Well, that was mostly until we sent satellites and we took pictures of the moon. But the thing is, uh, it's usually dark on the other side. Now, what we need to realize is a few key things about this. What is in your syllabus? In the syllabus, you have two things about this, about the moon. The two things are orbit and phases. All right. Now phases. How do we know the phase? What are the phases of these? Write the orbit 27 days in your notebook. Next thing is we'll start from here. from here. Read. Fair. Fair.
Mm-hmm. Phases of the
Read from
moon.
here.
Half of
Yeah.
the moon is always in sunlight, but we've seen an increasing, then decreasing proportion of that during the course of a month. The views above are from well north of the equator. For the view well south in Australia, for example, rotate each image of the moon by 180 degrees.
Okay. Guys, can you hear me?
Yep.
Yeah.
Yes, sir.
All right. Now it's really lagging out here. So let's continue. The next thing is moon reflects light. Sunlight. Well, another thing we need to know is no natural, let's say, does not emit light. It only reflects light. All right. Reflects light does not emit light. The thing is, it doesn't create its own light. Fine. Next thing we have to look at is what causes phases. Another thing we need to write is since moon is finish writing quickly. So they're not going to ask you to actually identify phases. You just need to know what causes phases, and we need to realize is that because of the periodic nature, we see different sides of the moon that creates these phases.
Wait, what about the phases?
The phases, that's what we need to know what causes the phases.
Oh,
Right?
okay.
You don't have to memorize the phases.
Moon does not revolve.
Just a second. Does not rotate. Rotate.
Yeah.
Rotate. Who has finished writing? Say yes, sir. Hurry up. Who has finished writing?
Done, sir.
Done.
Almost. Yeah, I think I'm done. Oh, you added a point. One second. Done.
Look at the book and Ayan, read from here. Not from there, just the beginning part.
Knowing the radius r of the moon's orbit around the Earth and the orbital period time for one orbit t, you can calculate the moon's orbital speed.
You can find the orbital speed. The equation is v equals to 2 pi r over t. Now, how do I find this 2 pi r? Well, where does that come from? Well, I know that the orbit is a circle, right? And since the orbit is a circle, let's go to the whiteboard. Since the orbit is a perfect circle, can someone tell me what is the circumference of the circle?
2 pi r.
2 pi r.
2 pi r. Now,
But how do we
Anas, yes,
circle?
how do we? Yes, say that, Amina.
How do we know if it's a perfect circle?
Well, it's not a perfect circle. That's why it's an approximation.
Exactly. I thought it was elliptical, but yeah.
Approximation. Well, we do have equations for elliptical orbits. Most of the orbits are elliptical, even the moon. And actually, the moon is going away from us. That's sad. Now, approximation of yes, orbital velocity. Write this in your notebook. Now we have make the diagram as well. We have this, all right. So we realize that the circumference must be equals to 2 pi r. All right. Another thing I know is how much time does it take to go from here, let's say from this point, all the way around to the point back. Now this whole thing must be 2 pi r, let's say 2 pi r, right? Now next thing I need to realize is how much time does it take? So if I say the time taken, time period, what is time period? Time taken for one oscillation is equal to capital T, then I can know that the time taken for the moon to travel this distance must be, well, time taken is T. And since I know velocity is distance divided by time, to be exact, displacement by time. And let's just call it distance for now, by time. And distance is around it is 2 pi r. So we'll write 2 pi r divided by capital T. Now, if they tell me that I know the radius, then I can totally find, and I know the time period and the radius, I can find the velocity. Let's try an example. Now, the example is, let's say, I know the radius is, how much is the time period, by the way?
27 days?
27 days. Let's make it exact, 27.3. And the radius is exactly going to be about 3.8 something. 3.8 into 10 raised by 5. Okay. And this is days. Fine, this is what I have. Now all I have to do is replace this in the equation. So let's use the equation now. V is equals to 2 pi r. Now can someone tell me if there's a problem here?
We need to convert days into hours.
Hours. Okay. Let's say km per hour. So how many days is how do I convert this? Well, if I'm going from smaller to the bigger, or if I'm going bigger to smaller, I will always multiply.
Multiply.
By 24, yeah.
And if I'm going smaller to bigger, divide by 20. Fine. Therefore, this will be how many hours? It will be 24 hours, not 24. This is going to be multiply 27 into 27.3 into 24. Tell me the answer.
655.2.
All right, 655.2. Now, all this knowledge we have today should be taken as a privilege. Because, guys, you know all of this, right? Imagine what you can do with how great a physicist you can be with all of this information. Back in the days, there was no internet, well, no calculators, and they found all of this. So with this, all of this, you can actually do a lot of projects and stuff. I want you to do projects, data. First, focus on this. Now, 655.2, that's fine. So 2 pi r is going to be 3.88 into 10 raised to power 5 divided by 655.2. And what is the velocity of the moon? Or the orbital velocity, by the way, not just velocity, but the orbital velocity. I want all of you to write the whole thing in your notebook, not just the definition, the whole example.
Can you scroll up?
Scroll up and Amina, can you see everything? Should I scroll up or down?
The text before this.
Text before this. This one?
Yeah, okay, I'm done with it.
Now, what is the answer? Tell me quick. Should I open my calculator on the screen, or you guys can handle it? Now, the first one to give the answer gets 2 points, right? Neha, try. Hurry up. The rest of you finish writing quickly. Guys, have you finished writing?
Yes, sir.
Now we'll focus on one more thing here.
I'm sorry about that. Someone called.
What is the subheading for this?
Subheading is exactly with the moon. You can call this phases of moon. Now you don't need to know exact phases, but you need to know why they happen. Some of them are important, such as the new moon and the full moon. Right? The new moon is when the moon is never there. You can't see the moon. And full moon is when you see the whole moon.
Sir, I have to go. I think class is done, right?
All right, just a second. Yeah. So we're done with the first part of the chapter. There are three parts of the chapter. Of this chapter and the next which we have. So please finish this quickly. Phases of moon, and we're done. That will finish. That will finish everything in the eighth part of the section. Earth and moon. Now, one last thing is the crescent, which you need to know is, or let's just,
Don't we have a waning, waxing, and a gibbous and all that?
now that's in the diagram, but they don't ask you why that happens, right? But they will ask
Yeah.
you why new moon and full moon happens. Is that clear?
Mm-hmm. Okay.
And crescent, just write it here. Crescent is partially visible. Let's just say partially illuminated from sunlight.
Okay.
That's it. Side facing Earth, it's partially illuminated from with sunlight. Yeah, that's it. Now finish this part and you're done.
Okay.
Now I have to give you some homework. The homework is, well, it's in the group. You have nuclear physics MCQ.
All right. All right. So do I leave now?
Who's going to recap? Quick, hurry up. Try recap.
Okay. Should I recap or?
Yeah, go on. Go on.
Okay.
What did we study
And
in this class?
yeah. So first we did Earth, and we did everything about Earth. The rotation, the revolution, and how the rising and setting of the sun, and how
All right. Stop.
it
Stop. Stop.
rises. Yeah.
All right. Continue. Amina. What else did we do? Hurry up. Recap.
Yeah, and then we did seasons, how seasons in northern hemisphere and how seasons cause change in position of rising and setting of sun.
Next thing we have is solar system. And then we'll have universe. These
Wait,
two
don't we
topics in
have
next class.
more phases of moon, or this is it?
Now there are a few more phases, which is in the book right here.
So we'll read it in the next class, or
We'll do questions on this
okay.
from the workbook, and we'll see what is asked on this, right? So don't worry about that. That's it. These are the phases. You should look at it, but in your syllabus booklet, they don't ask you to memorize it. But I'll check the questions in the workbook, and we'll do them. All right. So you have a proper idea of what is being asked. That's all for now. I hope you understood what we did so far. We're not trying to rush everything, but we're trying to understand it properly. And hopefully in the next class, we'll finish the chapter and we'll start practicing questions. All right, take care. Goodbye.
All right. Thank you. Bye.
Goodbye, sir. Take care.
Goodbye, Amina. Goodbye, Anas.
Wait, don't we have math right now?